This conference will now be recorded.
Okay. In the data warehouse, the data gets stored into two major tables. One is called as a master table, and the second one is a transaction table. This is about the terminology, the tables which stores data into the data warehouses. Okay, one is a master table and the another one is a transaction table. Coming to the master table, as we discussed, what is a dimension? Similarly, this master table which contains information about only the business. Got it? So it is going to store only descriptive information or textual information about this master table. Okay, this table contains information about the business. This is master tables. So in the real time, if you want to get any dimension information, they will usually say get the data from master tables. On top of master table, are there any tables created? So sometimes they don't give direct access to the master table. For example, I have a customer table. Okay, so they don't directly give an access to this customer table, because if I give an access to customer table, there is a lot of information available in the customer table, including their personal information. So there might be a chance of accessing their customer information. That's the reason they will create some view based on the requirement. Otherwise, due to multiple requirements, they will create one more table. Got it? So this is a master table in the data warehouse. Whereas comes to the transaction table, the table which stores metric information, metric information of the business, metric information of the business. What is the metric information of the business? The measures which belongs or which having the data types, integers, floats, floating numbers. So those all will be metrics. So what is the use of this? To analyze business performance. They usually get this data from the transaction tables. So if any data is not available, usually they will check in the transaction table first. If data is not available in the warehouse, means the data is not available, something happened at the back end, so the data might not be available in the source. So what is the source? It depends on the business, depends on the application. So sometimes business shares source files. Based on the application, there is a regular processor. So ETL usually get the data from various stakeholders. They will share the source files. Those source files get processed, loaded into the data warehouse. Okay. So if the data is not available in the transaction table, there are two cases. One is in the ETL, what they are doing the transformation in that layer, the data got eliminated due to various transformation made by the ETL team. So as per the conditions, as per the design of the ETL, if any one of the value is null, accordingly the entire records not being stored into the warehouse. Otherwise, there might be chance data unavailability in source file. So this source file processed through ETL and stored into the warehouses. So there are two ways, either ETL level the data got deleted, or in source file itself the data is not available. So such scenario cases usually faced by the reporting teams. Okay, like the way we have two type of tables, master tables and transaction tables. But the thing, usually primary keys. So when you are joining the data, any metric information of the business, what we have to do, we have to perform the joins between master table and the transaction table, correct? So as I said, without performing any join, it's not possible to get both information into your reporting system. So in the, as
Prem,
I said, yeah,
this master table and dimension table both are same, right?
master table and
Dimension table.
it's not like that. So in the data warehouse level, again these tables are classified into two types. Okay, so in the master table, in general, tables are classified again into dimensions and measure tables, or we can say fact tables. So let me give the architecture so that you will understand. Let's take this is a data warehouse. So usually data splitted into two tables. One is master table, another one is a transaction table. Okay, again, whereas comes to the next level of data, it again splitted into two types. One is a dimension table, another one is a measure table. So this also we can call as a fact table. Just give me a second, 1 second.
This conference will now be recorded.
Okay, so here also we have dimension tables. Here also we have a measure table. Okay, so in master table there are two type of tables, dimension and measure table. In the transaction table also we have two type of tables, dimensions and measure tables. Especially in master table, in 99% of cases, dimension tables, whatever the tables which is having descriptive information, can be considered as a dimension table. So there are measure tables which are defined with the integer data types. Okay, so those tables are going to store few unique ID level information. For example, a customer's Aadhaar number being saved into a table. Okay, so along with the Aadhaar number, there are few more details getting stored. So those all informations we can say that acts as a defined as a factor, means the data type might be integer. Okay, but it is part of a master table. So it cannot be part of a transaction table, because the data in the transaction table used to analyze business performance, This table does not fit to analyze business performance. Got it? So customer's mobile number is there, for example. Customer's contact ID is there. So this cannot be customer's address location, zip code is there. I mean postal code. Okay. So these are just examples, but as part of the business transactions, there are a lot more IDs generated, those stored into the fact to analyze. So there are flag informations are there, but whereas comes to the flag, as I said, it's quite reverse here. I'll continue with that. In 1% case, it is a dimension. In 99% cases, it is a factor. In 1% case, what is part of a transaction? As I said, flag information. So there are scenario cases to show Boolean expressions. The result of the Boolean is yes or no. Okay. So it is defined as a data type string. Okay, but the data stored as a string, but it acts as a still fact information. Okay, so such a type of information will be part of a transaction tables. The remaining cases, the data will be part of measure tables. As usual, what all are the measures? If any take sales business, such type of measure values will be part of this transaction tables. Like the way 99% cases, dimension tables are master tables, but it's not a permanent for all the cases. There is a 1% case, few details which is part of measure defined with integer data types, but that will be part of master tables. So like the way in data warehouse it is designed, this is just for example I given, but in the real time there are lot of IDs, lot of numbers get generated. Those will be shown into the, those will be part of a master table or a transaction tables. So one more thing we should understand, whereas comes to the dimension, so usually what can be called as a dimension? The table or column which contains a textual information plus must have a primary key defined on that. So those tables are the dimension tables. So whereas comes to the measure tables, which will have numeric data, I mean defined with n number of integer data types or number data types, and also it will have foreign keys. So like the way we can classify dimensions and measures. Dimension is nothing but the column or table which stores descriptive information, that can be called as a dimension. The table which stores metric information, that stores a measure table. So it's similar to the master table. Dimension is similar to the master's, measure table similar to the transaction. So sometimes in few cases, when you are looking for data in measure table, that will not be available because that might have integer data, but that will be stored in the part of master tables. Got it? Similarly, when you are searching for a few details, as I said, Boolean expression level of information, usually that will have true or false, yes or no statements. Okay, defined with the string data types. But if you search in a master table list, that will not be available. That will be part of this transactional level information. Okay, so that's a reason we have classified here. So and whereas comes to the, here it is master tables and transaction tables are classified, but the thing, whereas comes to dimensions specifically, those are again classified into n number of types. So based on the behavior of the table, based on the behavior of the data in the table, dimension tables again classified into multiple types. Multiple types. So what are those types? Is that required to learn about these dimension types? Yes, it is required. These all are the interview questions. So one is a slowly changing dimension. Any idea? We can call this as a SCD. Any idea about slowly changing dimension? Moreover, here we are discussing about a few details, not even full content about dimension types. Okay, so the important key dimension types we are discussing here. So based on the naming convention, what we can define the definition for this?
It stores the historical data.
No, so not the historically. So the data in this table changes over a period of time. Hence, this table is called as a slowly changing dimensions. So you can take any example here: age of a customer, age of a student. Okay, so when you are taking age of a student for two in 2023, what is the age? Let's assume 16 years. In 2024, age will be modified and shown as 17 years for any customer. So over a period of time, the data getting changed. Got it? And also there might be a request from the end users to change their names. Okay, so if the table which is supposed to change the name, those will be slowly changing dimensions. So here one more thing: in slowly changing dimension there are n number of types. So let's discuss about one by one. There are few three important types we have. Let's discuss about type 1. So what is the type 1? It does not maintain history of the data. It don't maintain history of data. In the real time when we are accessing master tables, in the later point of time business come up with this is the value or this is the data I used to have in the specific table. So can you give me the history of the table, history records in the table? So they are unable to provide because the table structure defined, it cannot be modified. It can be modified, but the new value always overrides the existing one. So when a value overrides the existing one, what happens? There is no history. Let's take a table like this: customer table, customer name, date of birth, okay, and the age. Okay. So for example, Prem is a customer we have. Okay. For example, his date of birth is X, X. Okay. His age is let's take 30 years. So when team got a request to change the age to 31, yes, they changed it, but there is no history if you look at. So I said not the Prem, my name is Prem space or. Yes, they renamed my customer name. Yes, in this case They are simply overwriting the existing value. It is not possible to retrieve the history of the record, history of the modified values. Okay, such a type of slow SCDs are called as type 1 SCDs. Got it? So let's take another example, SCD type 2. Okay, so in this table, the history values always maintained as a new row. Let's take here the history values maintained as new rows. So how to define a new row? For example, similarly, let's take the same example. Okay, this is a version information. V underscore 1. Okay, now the age is 31. Team got a requirement to make a change in the name. Yes, you can make a change. What is the name here? I'm changing to Prem. Similarly, remaining data is the same. Here, the version name get changed. What is the version name? V2. Okay, so to get the latest information, always. So let's take this as V1. Sorry, this as V2. Modified always the latest information always under V1. Okay, so when you are extracting the user information, you have to put a version for each select statement. You have to put a version is equal to V underscore 1. Correct? Then only you can able to get latest information of the customers from the customer table. This is updated information. So similarly, again I got a requirement. This is the same. Okay, this is 32. This is a 1. This is 2. This is a 3. Got it? What is the latest information? This is the latest information. So in this table, when a modifications are happening, the details are storing as a another row. The history information maintained as a other row. So based on the requirement, you have to extract we are authorized to extract a history of the records which updated for any customer. But the latest information flagged as a V underscore 1. Okay, this is a type 2 SCD dimension. So there is one more dimension, SCD type 3. So in the type 3, history maintained as a columns. Here also it is possible to store the history, but it is maintained as a columns. One second. This is the version, right? Let's okay. So this is the actual information, name, date of birth, and age. Now I got a requirement to make a change in the name. Yes, you can able to change the name. For example, I am modifying this name as only Prem. What is your previous name? This is my previous name. Here I'm giving the naming convention as a history 1. Later, again, there is a requirement to change the age of the customer. Yes, you can change frame. So details will be same. Here the age is 32. Okay. Here it is maintained as a column, right? Just underscore to here 31. As I said, it is added as a column. So what is the history age? 31. So like how many columns it gets stored? Yes, it stores up to the columns which are restricted by the database administrator. So for example, when I'm defining a table, I have given to store up to 32 columns, but original architecture is to maintain only 5 columns. When the history is getting updated, okay, if any customer's information exceeds more than 32, okay, the first history record get deleted. What is the first history? This is the first history, it get deleted. Let's take it's 33. Okay, some there are few changes made. So what is the first column? This is the first column, it get deleted dynamically. Got it? This like this the way we have slowly changing types. What is a type 1? Where is a type 1? This is. What is a type 1? In the type 1, the updated value always overrides the existing value. So there is no history maintained. In the type 2, there is a history maintained as a new record. Come to the type 3, history maintained as a new column. Got it? So like the way we have a slowly changing dimension, there are n number of types in the SCD, but we don't want that. The second type of dimension is rapidly changing dimension. What is the rapidly changing dimension? We can call this as a RCD. What is a rapidly changing dimension? So the data in this dimension changes rapidly. So we cannot stop the updating records into this rapidly changing dimensions. So what will be the examples for this? Time. So if you're defining any timetable, that is never be constant. Every second the data get changed. Correct? The values get changed. So timetables are the rapidly changing dimensions. For example, in a day, in a hour, in a minute, in a second, what is the customer count? If you want to extract that information, what you need? You must have a timetable for that. Then only you are authorized to extract this information. Got it? So those type of tables, those type of columns, the data in these dimension tables changes very rapidly. They never be constant. Okay, so that is a rapidly changing dimension. So unchanging or static dimension. The third one is a unchanging or a static dimension. So what is meant by unchanging or static? So the data in these dimensions are constant. I mean, it does not support to change. Let's leave it. The data in this dimension are constant, so are unchanged over a period of time. On time basis, on any other dependencies, the data cannot be changed. What type of data will be part of this unchanged dimension? Can you give me one example for this? For example, date of birth customer. So date of birth cannot be modified, right? Blood group of the customer, that cannot be modified. Gender of a customer, that cannot be modified. Okay, so like the way we have unchanging and static dimensions. So if any dimension does not fit to make a change in the data, those type of dimensions will be called as unchanging or static dimensions. So another one is a shrunken dimension. Shrunken dimension. What is the shrunken dimension? Any idea? The
No,
subpart or subset of one dimension called as a shrunken dimension. Example, subpart or subset of other dimension can be called as a shrunken dimension. For example, it's a parent-child relation. So, what we can give? So, in my businesses, I have a number of locations in which country table I have state table, I have cities table, I have postal codes. Leave the postal codes. Cities table I have. So states are sub part of the country. So Andhra Pradesh is not a part of any other country except India because it's a part of India. So state is a subpart or subset of a specific value in the higher dimension. That is India value. Okay. Similarly, cities which are part or subpart or subset of a specific state, those will be considered as a shrunken dimension. Here, state is a shrunken dimension to country, cities are shrunken dimension to the states. So it is a hierarchy level information, simply we can say. So such type of information we can call it as a shrunken dimension. Another one is a role playing dimension. What is a role playing dimension? For example, if any dimension that plays multiple roles with a fact or measure table Such a kind of dimensions can be called as a role playing dimensions. What type of dimension? Any dimension which plays multiple roles with the fact information. It must be placed multiple roles with the fact information or measure information. So then only we can call such a dimensions as a RPD, role playing dimensions. For example, in a retail business, I'm taking the reference as a date. So date is a dimension I am saying which plays multiple roles. How it plays multiple roles with the fact information. A customer have the customer information. Customer ordered the product. So the quantity, the sale amount, let's take 1000. He ordered one product with the 1000. That 1000, that is a fact information traveled throughout all the data dimensions. How? When the order placed on specific data, when is expected delivery data, so on, so data allocated for that. So what is the shipment data? Under the shipment dates, there will be multiple dates, correct? So that information we can call into somewhere. Hmm, where is history maintained here, right? So when a shipment is started delivering to the customer, it will place multiple roles. So shipment start date, shipment shipped date, shipment warehouse date, shipment out of delivery date, delivery date and time, accordingly shipment delivery date. Okay, if you look at these all are the dates comes from the date table. All these dates playing multiple roles with a single fact information or single measure information. Such a type of any dimensions if you have in your business, those considered as a role playing dimensions. So when they are creating the architecture of any business, they will define what all are the type of dimensions need in the architecture. Accordingly they will plan what all are the tables can be authorized to modified in the future, and what are cannot be authorized to modify in the future. Okay, so to define that type of architecture, first they will check what type of dimensions, what type of measures being utilized in the business. First they will estimate that, accordingly they will set up the architecture, accordingly they'll create tables and make a relations with the primaries and foreign tables. Got it? So like the way we have various type of dimensions. For example, we have another dimension, conformed dimension. Another dimension, conformed dimensions. What is a conformed dimension, sir? If any data in the dimension commonly shared throughout entire the business, such kind of dimensional tables called as a conformed dimension. If any data in the tables commonly shared throughout the business area, such type of dimensions called as a conformed dimensions. any enterprise. If you take any enterprise, okay, so what happening in the nowadays, they are not giving pay slips directly to the mails. So all the details maintained in the websites, in their company's websites, correct? You are charging your hours on daily basis, you are planning your leaves, okay, that is authorized through websites. I mean, they are maintaining some links, so whatever it is. So now all the data became automatic and very dynamic, stored into backend into the various tables, and there is a middle layer, they are processing that on monthly basis. Every month, fifth, second, you are receiving the pay slips, okay, that is stored into respective sites. How it is happening in the back end, the teams are working properly. So on your leave plan, it is reflecting, whenever you open the link, it is showing how many leaves you have taken, how many are available, how many optionals taken, how many optionals available, such information. So in the back end, the various database team is working. Why I am saying, in any enterprise, what is the details commonly shared throughout the business? HR contact details. So for example, in the HR contact details, it's not like a single HR, okay, and a single contact number. Not like that in nowadays, because if you take high scaled enterprises, they are maintaining n number of HRs, hundreds of thousands of HRs. They are working various locations, reporting to some other locations. Accordingly, their employees also reporting to the HR who is not in their base locations. They might be in Mumbai, but employees working from Chennai. Okay, so this HR tables, which are commonly shared throughout the business area. Along with that, you can take finance tables. This is commonly shared throughout the business. Why finance table? Who generate the pay slip? Finance teams generates the pay slip. Who make the amount? I mean, properly placed your salaries into your accounts. Okay, such a level of information commonly shared throughout the business area. That's what these are called as a conformed dimension. So one more thing, there are data tables defined in any enterprise. Why data tables are required? I mean, date and timetables. Timetables are defined. Why date and timetables are defined? So holidays list comes from the data tables. Okay, daily working hours comes from the data tables. Okay, what is the shift timings comes from the data tables. So this information commonly shared throughout the business areas. Commonly shared means not sharing these details in the mails, not sharing these details in the, I mean, through mails or through notepads, through WordPad. It's not like that. When you are entering your details in your systems, I am charging daily 9 hours. I'm working as I'm representing 9 hours in my business. Okay, I'm updating my details in my organization. Okay, what is the shift timing for you? That will be taken dynamically based on the timings. You will receive the respective allowances. Okay, it's not that much easy to design a architecture of a business. That's the reason date and timetables also commonly shared throughout the business areas. So such type of dimension information can be called as a conformed dimension. Got it? Like the way there are a few more dimension types. So it takes one more class to complete that. but there is fact information as well. There are fact table types are there. Okay, so there are three type of fact types. I think three more dimension types we have. Okay, we'll end up the session today. We'll connect Monday again. Before to that, just have a look into various type of dimensions which we discussed today. Okay, and mostly tomorrow onwards we will share these files as well. I will plan for that.